And in case of curvature and asymptotes, these are two applications. I have discussed about different formula to determine the curvature of any curve. It may be parametric form, it may be Cartesian, it may be polar, whatever it may be. Uh, Also, if you need, you can convert it to the another form, then you can also find the uh, curvature. And in case of asymptote also, mm, methods are discussed, different methods how to find the asymptotes. Asymptotes may be parallel to x-axis, parallel to y-axis, not parallel to neither x-axis nor y-axis. And in case of curvature, as I could remember, uh, I have discussed only about the curvature, and in this context, I would also like to discuss few words regarding the center of curvature and circle of curvature. Center of curvature and circle of curvature. Probably I have not discussed, though specifically it is not mentioned. Still, I think it would be better if I discuss this one. Okay, what is the center of curvature? You can you can write. You have to write the formula. It is not PDF. I will just discuss. Suppose if this is the x-axis and this is y-axis, and if it is the curve y equal to fx, suppose y equal to fx is the curve, and it at any point p, suppose this is the point, any point p x y, and if this is the tangent, and if this is the curvature, radius of curvature, and if you suppose this is the radius of curvature, and this length PC is the radius of curvature. Now, if you draw a circle at the point P with PC as the radius of the circle, then you will get the circle of curvature, and the point C is called the center of the curvature. So, if you draw a circle like this, with uh, uh, PC as the radius, uh, then you will get this is the circle of curvature and C is the center of curvature. Then how you will determine the center of curvature and radius of curvature? You just remember the formula that I will write here, that if uh, suppose if C xy is the coordinate of the point C, just if this point C is the coordinate xy, then the formula for x is x minus y1 into 1 plus y1 square by y2, and y equal to y plus 1 plus y1 square by y2. This is the center of curvature, formula for the center of curvature, capital X and capital Y. For the curve y equal to fx, y1 equal to dy dx, y2 d square y dx square. So, if the question is find the center of curvature at any point will be given, then suppose small x y is say for example at the point 2 3, then x equal to 2 y equal to 3, and you have to evaluate y1 y2 at the point 2 3, then you will get the center of curvature. And if nothing is given, any parametric form or anything is given, then also you can find evaluate the y1 y2 and x at that point and substitute here, you will get the center of curvature as xy. This is one thing. Another thing is, what will be the circle of curvature? Circle of curvature is x at any point p xy, uh, x minus center is what? X. So x minus capital X whole square, and y minus center is y coordinate is y capital Y. So that equal to what? That equal to radius square. Radius is what? Here the radius of curvature. So this is the center circle of curvature. Circle of curvature. So this is this x, capital X and capital Y are the coordinate of the center of curvature, and this x minus capital X whole square plus y minus capital Y whole square equal to rho square is the circle of curvature. And this rho, the radius of curvature, and here for the circle it is the radius. So this is one formula to determine the radius, circle center of curvature, radius of circle of curvature. Another formula is, I would suggest you to note it. Okay, next the length of the curvature, chord of curvature, chord of curvature. And in case of chord of curvature, we have to find the length of the chord of curvature. Suppose if you consider any chord like this, say parallel to x-axis or parallel to y-axis, usually we will determine that. Then the length of the chord of curvature parallel to x-axis, parallel to x-axis is 2y1 into 1 plus y1 square by y2, and parallel to y-axis is 2 into 1 plus y1 square by y2. This is the length of the chord parallel to x-axis. This is the length of the chord parallel to the y-axis. So these formulas you should remember if required, if any small problems are given based on the center of curvature, circle of curvature, or if the question is find the length of the chord parallel to x-axis or parallel to y-axis, then you just use this formula and evaluate the length of the chord. Is it noted? Then I will give one example. Okay, so I think you have already written. Now take one example. So that so that the parabolas so that the parabolas y equal to minus x square plus x plus 1, y equal to minus x square plus x plus 1, and another parabola x equal to minus y square plus y plus 1 have the same circle of curvature. Both have the same circle of curvature. Where? At the point 1 1. So this is the question. So that the parabolas y equal to minus x square plus x plus 1, x equal to minus y square plus y plus 1 have the same circle of curvature at the point 1 1. So you have to find the circle of curvature for 1, and then you have to find the circle of curvature for 2, and you have to check that both are equal. So I will first find for the circle of curvature for 1, and you have to check whether for 2 it is correct, the same or not. So if I consider 1, then y equal to minus x square plus x plus 1. Then what? Y1 equal to minus 2x plus 1. Y2 equal to minus 2. So if you consider the point 1 1, at 1 1, y1 equal to what? Y1 equal to minus 1 and y2 equal to minus 2. So for circle of curvature formula is what? X minus whole square plus y minus y whole square equal to rho square. So what you have to determine? You have to determine the center of curvature. You have to determine the radius of curvature. Then only you can find the circle of curvature. So what is the formula for the radius of curvature? Rho equal to 1 plus y1 square whole to the power 3 by 2 by y2. This is the formula for the radius of curvature. That is equal to, if you substitute all these are, then its value is minus root 2, but you know that the radius of curvature cannot be negative because it is a length. So you have to take the radius of curvature as root 2, and the center of curvature formula is what? X equal to x minus y1 into 1 plus y1 square by y2. That is equal to 1 plus y1 square, y1 into this and y2. So if you substitute all these, 1 plus 1 2, 1 minus 1, that is 0, and y, that is equal to y plus 1 plus y1 square by y2, that is equal to y equal to 1 plus 1 plus 2 by minus 2, that is also equal to 0. So the center of curvature is 0, 0. Center of curvature is 0, 0. Now radius of curvature is rho equal to root 2. Center of curvature is this. So what will be the circle of curvature? This is the formula: x minus capital X whole square plus y minus capital Y whole square equal to rho square, that is x minus 0 whole square plus y minus 0 whole square equal to root 2 square, that is the circle of curvature is x square plus y square equal to 2. Similarly, you have to find the circle of curvature for the second curve, and you will find that this is also x square plus y square equal to 2. So what you have to do? You have to remember the formula for the center of curvature, formula for the radius of curvature, formula for the circle of curvature. Hello? Hello, I am audible?
Yes,
Yes, sir.
sir.
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
You are audible.
So this is one example. Similarly, you can find I am not. I will not discuss much more, but you just remember the formulas for the curves, and it is not so difficult. Uh, as you have to determine the radius of curvature. Already I have defined the radius of curvature and solved some examples. It is not so difficult to find the radius of curvature. And then you have to find the center of curvature using the formula. So nothing to do, you have to just simply remember the formula, and then you will get the circle of curvature. This is one thing. And if you have copied, then I will take another problem. Okay. So though I have discussed about the asymptotes, INM method, and also asymptotes parallel to x-axis, parallel to y-axis, but I will discuss one example, and why I have taken this example, I am coming to that point later. Find the asymptotes of the curve. Find the asymptotes of the curve y to the power 4 minus 2x y cube plus 2x cube y minus x to the power 4 minus 3x cube plus 3x square y plus 3x square y plus 3x y square minus 3y cube plus minus 2x square plus 2y square minus 1 equal to 0. So y to the power 4 minus 2xy cube plus 2x cube y minus x to the power 4 minus 3x cube plus 3x square y plus 3xy square minus 3y cube minus 2x square plus 2y square minus 1 equal to 0. So there is nothing new in this problem, but still I have considered this is an example. It is a 4-degree equation, and look at this, both y to the power 4 and x to the power 4 are present in the problem. When I have discussed about the asymptotes, I told you that if it is a curve, suppose for a cubic equation, but y cube is not present, then there are asymptotes parallel to y axis. There are x cube is not present, then there are asymptotes parallel to x axis. Similarly, if you take a 4-degree equation, then if y to the power 4 not present, then you will get some asymptotes parallel to y axis, and if x to the power 4 are not present, some asymptotes parallel to x axis. But here y to the power 4, x to the power both are present. So there are no asymptotes either parallel to x axis or parallel to y axis. Still I have taken this example. Why? Okay. Uh, let asymptote is what? We assume asymptote is y equal to mx plus c. And here no asymptotes parallel to either x axis or y axis. So m of course not equal to 0 here, because if m equal to 0, then y equal to c. Y equal to c means what? It is asymptotes parallel to y equal to constant means parallel to x axis. But we have checked that there are no asymptotes parallel to y axis, or no parallel to x axis. If you at least write this sentence, also you will get at least 1 mark. If you made mistake in other steps and you are not getting your asymptotes, still you will get at least 1 marks, that you have find that there are no asymptotes parallel to x axis, no asymptote parallel to y axis. Okay, anyway, then when we use phi nm method, we take what? We take x equal to 1, y equal to m. This is the working procedure. Taking x equal to 1 and y equal to m, we get what? We get here highest degree is 4. So 5 4m equal to m to the power 4 minus 2m cube plus 2m minus 1. 5 3m equal to minus 3 plus 3m plus 3m square minus 3m cube. Phi 2m equal to minus 2 plus 2m square, and phi 1m equal to 0. Then what you have to do? What you have to do? First, you have to set phi nm equal to 0. Phi 4m equal to 0. And you have to find the 4 values of m. So phi 4 equal to m equal to 0. Could you find the values of m from here?
One, sir.
1. Okay. 1 is, one value is 1, but it is 4-degree equation. Still there are some
Minus
asymptotes.
one.
Sorry. Huh?
Minus one.
Okay. 1 and
Yes,
minus
sir.
1.
Minus one.
Okay. So one root is 1, another root is minus 1, but it is 4-degree equation. Sorry. It is 4-degree equation. Still there are 2 roots. So if you can find 1 and minus 1, then it is not so difficult to find the other rule. Why? Because m minus 1 and m plus 1 are two factors. So from here, if you can find, you will find that actually the roots are 1, sorry, roots are 1, 1, 1 and minus 1. So if the roots are like 1.5, then it is not so difficult. Sorry, it will be very difficult, but usually in exam it will not be given in this way. So that here you can find the roots. But my intention is not to find how you will find the roots. My intention is different. That's why I have taken the exam. You your roots are found, and three roots are one, and one root is uh, one root is minus one. So look at this here. Three roots are equal. Three roots are equal. Then how you will find the c corresponding to 1? For minus 1, it is no problem. The formula is C equal to minus phi 3 minus 1 by phi 4 dash minus 1 at m equal to minus 1. This is the formula. But if there is repeated roots, then this formula failed. Why? Because this denominator term will be 0 at 1. Because here actually phi 4m equal to m minus 1 whole cube into m plus 1. Because three roots are repeated 1, 1, 1, so there must be a factor like this m minus 1 whole cube into m plus 1. So if you differentiate this phi 4m, still there will be a factor m minus 1 whole square, that is at 1, this equal to 0. So you cannot use this formula. I have solved, but up to 2 repeated roots. Here I have considered 3 repeated roots. So how you will find the other c corresponding to m equal to 1? So if you have written already this example, the formula will be what? Formula will be c cube by 3 factorial phi 4 triple dash 1 plus c square by 2 factorial phi 3 double dash 1 plus c phi 2 dash 1 plus phi 1 1, this equal to 0. Look at this. So here it is a cubic equation of c. From here you will get 3 values of c corresponding to m equal to 1, 1, 1. So differentiate phi 4 3 times, differentiate phi 3 2 times, phi 2 1 times, and then phi 1. Where? At the point 1, 1. So all m would be replaced by 1. So from here you will get, you can try c equal to 0, 1, 2. So for 1, 1, for m equal to 1, once you will take 0. For m equal to another one, you will take 1. For m equal to another one, you will take m equal to 2. Sorry, c equal to 2. So you will get the 4 asymptotes. Or if the roots are, luckily you will get the equation for which the roots are different, then no problem. Then just use this formula. If it is a cubic equation, then it would be 2, it 3. But here it is 4th degree equation, that's why it is 3 and 4. So that's why I have taken this example, that there are 3 repeated roots. And if there are 2 repeated roots, already I have discussed, then you will start from C2, C square, from here, not from here. So in this way, you will get the all the values of the M and all the values of the C. Okay, this is one example that I decided to discuss. And one thing, you are now staying in the hostel or in home?
Sir, we are coming from 6 April onward.
Oh, in the April you are coming. Okay. But probably throughout the first semester, your class will be online, as I received the information. Maybe your exam will be in offline mode. Okay, this is one example. So, and as I understand that two of you did not appear to the class test, I will uh, I will arrange anyway. I will arrange to evaluate. Okay, so that I have decided uh, one thing, application. Uh, just a moment. Suppose in multiple integral that I have discussed, that the double integral are say the function is fxy dx dy. It is the multiple integral of the function fxy. Suppose the region R is the region this. If instead of this, the question is find the area of the region R, then how you will evaluate the area of the region R?
Double integral dx dy.
Double integral dx dy. That is, in that case, you will take this equal to 1. You are evaluating this integral over this region. But if your question is find the area of the region, then take this equal to 1. That is, actually you have to find this dy. It is the same thing as you, it is the same thing. It is divided into small elementary area. Say take any general area is if it dy, if it dx, then area is dy dx, elementary area. And if you take the sum over whole region, then you will get this one, that is the area of the region. So now I will give one example to evaluate the area of the region. Okay, let us take one example. Uh, Evaluate the area, evaluate the area of the region, evaluate the area of the region bounded by the parabolas bounded by the parabola y square equal to x and x square equal to y. This is the question. Find the area of the region bounded by the parabola. In that case, I would always suggest you first uh, draw the area represented by the curves. Then it will be easier to evaluate. Here y, this x, this y, one curve is this, and uh, no, sorry, uh, y square equal to x square equal to y, and another is x square equal to y square equal to x. So the region bounded by the curves is this one. This is the portion you have to evaluate. So this curve is y equal to x square, and this curve is x square equal, x equal to y x square equal x equal to y square. So your task is to evaluate r dx dy or dy dx as you like. Now give the limit of this two integral dx dy or dy dx as you like. What will be the limit? Range of integration? Suppose if you take instead of x, if you take y first, then it is dy dx. You can take x first, no problem. So what will be, just I am asking you that what will be the limit of y from where to where, and what will be the limit of x from where to where?
X will be 0 to 1.
X is 0 to 1, okay, and
Y
y?
will be 0 to x
0
square.
to 1. Y
Y
will be
is
x square
what?
to root x.
Y
X
equal
square to
to
Y,
root
x
x.
square to root x,
Root
yes.
x.
X square to root x. Actually, y varies from any point on this curve to here. This. So any point on this curve, y is what? Y equal to x square. And any point y on this curve is y square equal to x, y equal to root x. So y equal to x square to root x dy dx. And x varies from, because this point is 1 1. If you intersect this y equal to x square and x equal to y square, you will get this point as 1 1. So here x equal to 0 and here x equal to 1. So x varies from 0 to 1. So this is one application of the double integral. And similar type one example, find the area in the first quadrant. If you would like to write this example, first write it, then I am giving another example. Also, I have discussed about the Jacobian. I will give you one example and you have to find the Jacobian of the transformation. Okay, I am giving another example. Uh, Probably I have solved this example. I could not remember. Check. If not, then you can solve it. This is also one famous example. 1 minus x square minus y square by 1 plus x square plus y square dx dy over the positive quadrant of the circle x square plus y square equal to 1. Is it solved?
No, sir.
Okay, then you can proceed. You don't have to complete, at least give some hints that how we can proceed to evaluate this example. Why I have given this example? Because look at this, here it is uh, square root, there this function is given in the square root, and here the functions that we have taken 1 minus x square minus y square by 1 plus x square plus y square, something known to us, looks like this. So could you give any idea that we can proceed in this way so that it becomes easier to evaluate?
Sir, x equal to r cos theta, y equal to r sin
Sir,
theta.
r cos theta.
X equal to r cos theta, y equal to r sin theta. Yes, you can proceed in this way. In this way, so it becomes easier because here x square plus y square equal to 1, and also look at this within the square root 1 minus x square plus y square. So it will be 1 minus r square, and in the denominator it will be 1 plus r square. Yes, you can proceed. It is you can do it in the first quadrant. You must, when you will put the limit, you must remember that it is in the first quadrant. So if you take this transformation x equal to r cos theta, y equal to r sin theta, then as it is a circle, then if it is theta and it is r varies from 0 to 1, radius 1, r varies from 0 to 1, and theta varies from 0 to pi by 2. And in that case, what is the Jacobian? Because you cannot directly write that dx dy equal to dr d theta. You have to write this Jacobian into dr d theta. So what is the Jacobian?
Sir, del of x comma y upon del of r comma
Uh,
theta.
del of,
Sir, x comma y.
actually you can yes, I got it. If you write in determinant form, then del x del r,
Sir, del
del
x
x
del r, del x del theta,
uh,
and del y
del
del
y
r,
del r,
del y del theta.
del y del theta.
Del y
Yes.
del theta.
Now evaluate this.
Sir, this is r, sir.
R.
The answer is r.
So this equal to r dr d theta. So this integral becomes r equal to 0 to 1, theta equal to 0 to pi by 2. This is root over of 1 minus r square by 1 plus r square. Uh, r d theta dr. Now look at this. Here theta and r are independent. So you can do it like this: theta equal to 0 to pi by 2 d theta, and r equal to 0 to 1 root over of 1 minus r square by 1 plus r square dr. Oh, sorry, r into dr. So you have to evaluate this one, and from your class 2 level, this integral is, I think, known to you, so you can do it, no problem. In this way, you have to evaluate. Uh, okay, I will give you one. Okay, So if it is completed, I will give you an example to evaluate the Jacobian only. Okay. If x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta, find the Jacobian for this transformation. Do you know this coordinate system? Anybody? You know that x equal to r cos theta, y equal to r sin theta. That is circular system in plane, two-dimensional case. But here we have considered it is in three-dimensional case, and here x, y, z. Actually, this is what? It is actually the spherical coordinate system. Its name is spherical coordinate system. That is, when we represent a circle, then x and r and theta, and when we represent a sphere in three-dimensional case, we represent it by theta and phi. Not only it will move, sorry, not only it will move in this way, that from here to here, here. It also move in the along z axis. That's why another coordinate is taken, that is phi. So now evaluate this one for this system: x equal to r sin theta cos phi, y equal to r sin theta sin phi, and z equal to r cos theta. Just 1 minute, I am coming. Hello, you got it?
Hello, sir. Will it be 2 cross 3
Yes.
determinant?
No, no, no. 3 by 3 determinant. Determinant never be rectangular. It is always square. Sorry, sorry. Uh, uh, Actually,
I
del
mean, sir, for the Jacobian.
Jacobian, del x, del r, del x, del theta, del x, del phi, del y, del r, del y, del theta, del y, del phi, del z, del r, del z, del theta, del z, del phi. Now evaluate. This is 3 by 3 determinant.
Sir, the answer should be r square sine theta.
R square sine theta. Yes, this is the answer. Okay, so instead of transformation of variable, sometimes question may be find the Jacobian for this transformation only. Then you have to do in this way. And I think this problem is given in your class test. U equal to f of y by x plus root over of x square plus y square. Then find x del u del x plus y del u del y. Is it solved by everybody?
Yes, sir.
Okay,
Yes,
then
sir.
I am not going to this problem. Similar type example, almost similar, not exactly similar. Another example. Uh, U equal to x f y by x plus g y by x. Then show that x square del square f del y del x plus 2xy del square f del x del y I think there is a mistake in this problem. Y square del square u del y square equal to 0. I think it would be del x square. So uh, first what you will do, just tell me, you don't have to do here. U equal to x f y by x. So if you consider u equal to v plus w, then v is a homogeneous function of degree what?
1.
1.
One.
Sir, one, sir.
W is and w is a homogeneous
Sir,
function of
0.
degree
Zero.
0. So now you can proceed. Now it is not so difficult, but first you have to do in this way, then it will be easier to evaluate. Just for this reason I have considered this example. Okay, then another example, you will try it. I am not solving here. Determine the area, determine the area bounded by the curves, bounded by the curves xy equal to 2, 4y equal to x square and y equal to 4. You will do it. If not possible, then I will help you. And I think it is not so difficult that you will not do. Determine the area bounded by the curves xy equal to 2, 4y equal to x square and y equal to 4. Xy equal to 2, you know that it is a rectangular hyperbola. So first you have to draw the picture, then from the picture you have to evaluate this one. If I am taking another example, if it is already solved, then you don't have to do, but if not, then try to solve it. A square b square minus b square x square minus a square y square by a square b square plus b square x square plus a square y square dx dy over the positive quadrant of the ellipse, positive quadrant of the ellipse, x square by a square plus y square by b square equal to 1. For the positive quadrant of the ellipse, x square by a square plus y square by b square equal to 1. Is it solved? Hello, I am audible.
Yes, sir.
Yes, sir.
Okay. Is it solved or not? If not, then look at this. This is on ellipse, not circle. If it is a circle, usually we consider x equal to r cos theta, y equal to r sin theta. But if it is ellipse, so here look at this. Usually, when we find any ellipse, first our intention is to convert this ellipse to a circle. So, if you give a transformation x equal to say AU, y equal to BV, then it will be u square plus v square equal to 1 circle. So, instead of giving two separate transformation, then again you have to give u equal to r cos theta, v equal to r sin theta. So, instead of giving this, you can also use, just a moment, you can also use x equal to a r cos theta, y equal to b r sin theta. If you give this transformation, then you don't have to do two transformations separately. Here, Jacobian will be a b r instead of r, a b r, and then it will be easier to evaluate the same thing that you have done for the earlier example that I have taken, because you know that this, if you divide it by a square b square, it will be 1 minus x square by a square, y square by b square, and in the denominator it is 1 plus x square by a square plus y square by b square. So if you give this transformation, then it will be dx dy equal to a b r dr d theta, and then you can evaluate it as you know how to evaluate integral in one dimensional, because it will be separated by r and theta, both are independent integral here, and then evaluate independently for theta, independently for r. Okay, so next one example. Next example is express express 0 to 1 0 to 1 x square to 2 minus x fxy dy dx as a sum of two double integrals. Sum of two double integrals. Express this. So what you have to do, First, what you have to do? You have to do the picture of the region of integration. So you know that this integral x square to 2 minus x means it is the limit of y, and this x equal to 0 to 1, because x limit is given in terms of x means it is the limit of y variable. So draw the picture: y equal to x square, y equal to 2 minus x equal to 0, x equal to 1. So if you draw the picture x and y here, then first draw x square equal to y. X square equal to y is the parabola, this one, and then line is what? X plus y equal to 2 minus x, that is x plus y equal to 2. X plus y equal to 2 means it is just like this one, and another x equal to 0. X equal to 0 means this line, and x equal to 0, x equal to 1, x equal to 1. So first evaluate this point. What if y equal to 2 minus x, so x square plus x plus 2, no, what, y equal to x square, y equal to 2 minus x, so this point is
One.
x square equal to
Sir, 1 1.
sorry, this is minus, so it is 1 1 point, 1 1. So if it is 1 1, then x equal to line will pass through this point. So the your region of integration is what? This one. This is the region of integration. And the your question is express dy dx as a sum of two double integrals. So what, any idea what, how you will divide it into as a sum of two double integrals? Even if it is not given that divide it into two double integral, then also you can do it to evaluate this one. But here you cannot evaluate because fxy is not given. If fxy is given, then you can evaluate. However, the question is express the sum of two double integrals. So look at this. If you consider this one, this is one region, this is one region, because after this the curve is changed, this one, and before this the curve is this one. So if you consider it is a double, just two double integral, then the given integral if I, then I can be written as plus this. So if you consider for this region is what? Y varies, x varies from 0 to 0 to this curve is x, x varies from root y, x varies from 0 to root y, 0 to root y, and y varies from 0 to 1, y varies from 0 to 1. And here it is first dx, then dy, here fxy. And for the second integral, x varies from here to here, means 0, x varies from 0 to on this line means x equal to 2 minus y, 2 minus y, and y varies from here to here, that is y equal to 1, and this point is 2, 1 to 2, fxy dy dx. In this way you can find the you can express the integral as a sum of two double integrals. Is it clear? Hello.
Yes, sir, clear.
And if the question is nothing is given, express this is a sum of two double integrals, and fxy, suppose this fxy is given, say for example x into y, then you can also express it as a sum of two double, then you can evaluate. Otherwise, if you don't like to express it as a sum of two double integrals, then you have to do, just a moment. Oh, okay. Uh, this is the area. Then what you have to do, if you don't like to express it as a sum of two double integrals, but you have to evaluate, then y you have to consider first from this curve to this curve, and then x varies from 0 to 1. Then also it is possible to evaluate, but here the question is express the sum of two double integrals as a sum of two double integrals. Then you have to consider y varies from 0 to 1. Is it clear?
1. Yes, sir, clear.
1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1.